These short questions are from different areas of chemistry. Part A. Explain why a CF4 molecule has polar bonds but does not have an overall dipole. CF4 has polar bonds because F, or fluorine, is more electronegative than carbon. However, it doesn't have an overall dipole, or CF4 doesn't have an overall dipole, because the compound is symmetrical, and therefore if a compound is symmetrical, the dipoles are going to cancel out. To get the 2 marks for this question, you must say that F is more electronegative than carbon, and that CF4 is symmetrical, so the dipoles cancel out. This gets you your 2 marks for this question. Part B. Explain why a small proportion of molecules in water have a relative molecular mass of 20. The reason why molecules in water might have a relative molecular mass of 20 is because the molecules contain isotopes of hydrogen. So the isotopes of hydrogen are deuterium and tritium. To get the mark for this question, you must say molecules contain deuterium and tritium. Part C. What is the partial pressure of O2 in pascals in a gas mixture containing 21% of O2 by volume and with a total pressure of 1.0 times 10 to the 5 pascals? Firstly, let's highlight the key pieces of information. We're working out the partial pressure of oxygen in pascals, and we've got 21% of oxygen and a total pressure of 1.0 times 10 to the 5 pascals. So partial pressure is the molar fraction times the total pressure. So our molar fraction is 21%, but we need to divide by 100. We divide by 100 to get the mole fraction rather than the mole percentage. So that would be 0.21, and then we multiply by the total pressure, which is 1.0 times 10 to the 5 pascals. And that gives us 2.1 times 10 to the 4 pascals as our partial pressure of oxygen. So to get the mark for this question, we need to write 2.1 times 10 to the 4 on the answer line provided. Part D. What mass of carbon dioxide in grams is formed by the complete combustion of 42.0 meters cubed measured at room temperature and pressure of propane? The first thing we need to do is write some key equations. So our first key equation is that volume divided by molar volume. So the molar volume could be 24 decimeters cubed or 2,400 centimeters cubed. That equals moles. So we've been given 42 meters cubed. Converting this to decimeters cubed, we would get 42 times 10 to the 3, or we multiply by 1,000. Then we can do 42 times 10 to the 3 divided by 24. This equation only works if we're measuring at room temperature and pressure. But because we can use this equation, and that gives us 1,750 moles of propane, which is C3H8. Then we're trying to work out the mass of carbon dioxide. So we're going to use the equation of mass divided by moles times relative formula mass. This is the equation triangle we're going to be using. So if we wrote the equation for complete combustion, that would be C3H8 plus O2 goes to CO2 plus H2O. Then balancing this, we would have 3 CO2, then we would get 4 H2O and 5 oxygens. So then if we use this balanced equation to work out the moles of carbon dioxide, that would be 1,750 multiplied by 3, because we've got 3 times as many carbon dioxides as we have propane. Then using the equation triangle, we multiply moles by relative formula mass. Relative formula mass of carbon dioxide would be 12 plus 16 times 2, and that equals 2.31 times 10 to the 5 grams of carbon dioxide. So we write this on the answer line provided. So we write 2.31 times 10 to the 5. For this question, you get a mark for working out the moles of propane and a mark for working out the mass of carbon dioxide correctly. Part E. A reaction is first order with respect to H+, at a pH of 1. The initial rate is 2.4 times 10 to the negative 3 moles, decimeters to the minus 3, seconds to the minus 1. What is the initial rate at a pH of 3? When you make a pH more basic, you decrease the initial rate by a factor of 10 to the n, where n is the amount that you've made it more basic. So with this question, the pH has gone from 1 to 3. So that's n equals 2 because we've gone from 1 to 3. So that means we're going to do 2.4 times 10 to the negative 3, which is our initial rate. And then we're going to divide by 10 squared because n is equal to 2. That gives us 2.4 times 10 to the negative 5 moles, decimeters to the minus 3, seconds to the minus 1. And this is our new initial rate at a pH of 3. It's decreased by a factor of 100. So to get the mark for this question, write 2.4 times 10 to the negative 5 on the answer line provided. Part F. What is the number of oxygen atoms in 4.26 grams of P2O5? With this question, we're going to use the equation triangle mass moles times RFM. So firstly, what we're going to try and do is work out the moles of P2O5. So that would be 4.26 divided by 31 times 2 plus 16 times 5. That gives us 0.03 moles of P2O5. So what we've done is we've used the mass of P2O5 and we've worked out the relative formula mass to work out the moles of P2O5. Now we need to work out the number of oxygen atoms, so we're going to do 0.03 times 5. This is because there are 5 oxygens in P2O5, and we're going to multiply all of this by Avogadro's constant, which is 6.02 times 10 to the 23. That gives us 9.03 times 10 to the 22 atoms of oxygen. So we write this on the answer line for this question, 9.03 times 10 to the 22. To get the marks for this question, you get a mark for working out the moles in P2O5, so 0.03, and then you get a mark for working out the number of oxygen atoms correctly, so 9.03 times 10 to the 22.